Welcome back, mathematicians. In this video, we're going to look at absolute value inequalities, and we're going to focus on greater than inequalities. What that means is we'll have the absolute value of a variable expression greater than or possibly greater than or equal to a value. In this case, I'm going to look at an example to help understand how to solve these, which is the absolute value of x is greater than or equal to 3, but this could also be true for greater than 3 instead of greater than or equal to 3. So let's go ahead and understand what this means by absolute value greater than or equal to 3. It means the values for x are going to be values that are a distance from 0 on the number line greater than or equal to 3. So let's put 0 on our number line, and let's put values that have at a distance of exactly 3 units from 0, which would be 3 and -3. So those values both have a distance of exactly 3 units from 0. But we are not just looking at values that have exactly a distance of 3 units. We're looking at values that also have a distance that are greater than 3 units. And so the values that have distances greater than 3 units from 0 are going to be values that are represented here on a number line. In other words, 4, 5, 6, 7, 8, and all the decimals in between. And also over here on a number line, which is going to be -4, -3, -6, etc., and all the decimals in between. Now we also must think about 3 and -3. Because of the fact that it's got the equal to part, we have to include 3 and -3 in our solution set, which means we would put brackets here on 3 and -3, a bracket on 3 opening to the right, and a bracket on -3 opening to the left. Well, what does this mean? This means that we can actually convert the absolute value of x is greater than or equal to 3 into a compound inequality. And this becomes an OR compound inequality. So we've got one inequality, which is x is greater than or equal to 3. That's this part of the number line. And then we've got the other part of the number line, which is represented as x is less than or equal to -3. So we can convert this absolute value inequality into this compound inequality and then solve if necessary. So let's use this to come up with a general rule. And we're going to start by letting u equal some variable expression. And what this means is that if we have the absolute value of some variable expression and it is greater than or perhaps greater than or equal to some constant, we'll say a, then this is equivalent to a compound inequality. U is greater than a, or u is less than the opposite of a. Now let's go ahead and apply that rule to this inequality. So we have the absolute value of 2x minus 3, which is greater than or equal to +6. So to start, I'm going to let this variable expression be u. So I'm going to say that the distance from 0 on the number line for u has to be greater than or equal to 6. So we put 0 on our number line, we put the boundaries of 6 and -6 on our number line because those values have a distance of exactly 6 units from 0. And now I'm looking for values that have a distance that is greater than 6. And that would be represented on our number line as these values. So 7, 8, 9 on to infinity, and we include decimals, and also -6, -7, -9, all the way to negative infinity, and we also include all decimals and fractions. So do we include -6 and +6 in that solution set? And the answer is yes, because of the inequality symbol, because it has the equal to part. So I'm going to put brackets around or on 6 and -6 opening to the right and left. So what I can do now is transition from that number line to a compound inequality. And this is a way to do it instead of memorizing the rule. So I have u, which I know is greater than or equal to +6, and I've got u, which I know is less than or equal to -6, and this is an OR compound inequality. So now I can go ahead and replace u with 2x minus 3, the variable expression I said was equal to u, and it's less than or equal to -6, or 2x minus 3 is greater than or equal to +6. From here, I'm going to solve both of these inequalities. So I'm going to add 3 to both sides, and what we notice is that the steps are the same for both inequalities, so I'm going to add 3 to both sides on the other inequality. That cancels the 3 out on the left side for both inequalities, leaving me with 2x is less than or equal to -3, or 2x is greater than or equal to 9. Now I'm going to go ahead and divide by 2 to both sides, so I get a coefficient of 1 in front of my x, and so I have x is less than or equal to -3 halves, or x is greater than or equal to 9 halves. So that's the solution set in inequality form. You might be asked to represent this in interval notation. Each of these inequalities will represent its own interval for the solution set. So for this inequality, it doesn't have a left bound, so we represent that as negative infinity. It does, however, have a right bound of negative 3 halves. Because it's equal to negative 3 halves, we put a bracket. We then separate this with a union symbol, and this will be the second inequality will represent itself as the left bound of 9 halves, and it's equal to 9 halves because the inequality symbol does have the equal to part, and it goes to infinity. All right, guys, good luck.